Hello everyone, my name is Drew Jordahl and I'll be walking you through our post-challenge breakdown. So our team member consisted of me, Drew Jordahl, Isaac Cruz, Rhiannon Markegard, and Dr. James Lee. As you can see pictured to the right, that is the three of us doing the fly-off. So just before we get down into the data, we'll have a quick hardware review. So picture on the top left is the temperature, altitude, and magnetometer suite. In terms of connecting the suite to the drone, a 3D printed bracket was made and then bolted onto a soldered breadboard, as you can see in the picture. And then soldered to this breadboard is a modular hat connection system. So basically, you can slot the pins of the Teensy 3.5 into this solder breadboard with the other sensor, with the sensors attached to it. And then during the fly-off, we took out the Teensy off of this board and then put it into the LiDAR unit before flying that. Which is pictured below. Speaking of which, as you can see, the LiDAR unit is on the front to collect the distance, and then kind of snaking the wires to the top is connected is a servo motor with a laser pointer. So as a reminder, the idea of this is that first knowing the height of where the servo motor is off the ground for an offset, and the distance of the object you were trying to calculate the height of, I can then wirelessly tell the servo motor to rotate and point the laser pointer at a specific angle. And when the laser pointer lines up at the top of the object, I then know what angle to use in terms of triangulation of the height. And doing this requires using serial communication and the 2.4 gigahertz transceivers that we had from SparkFun. And so basically I would type in angle commands into the computer, and then the home base setup as pictured on the right would then send that information to the drone, and then which can both take a LiDAR distance measurement and also rotate the servo motor. So getting first into the map and photograph data that we collected, I created a map of the unknown area, first showing general positions of important landmarks, the tables, the towers, where the liquid collection bucket is, where all the targets are, and then also shown as distance and height data, and then I also included the photography targets at each location. First, going on the height of the tower, or of the table, let's talk about that first. The table was 78.3 centimeters from the ground, and then from position X to the edge of the table was measured at 258 centimeters. Doing a reality check as to is this measurement even remotely accurate, the height of the 78.3 centimeters off the top is around 3.5 feet or so, and that seems somewhat reasonable for the height of a table. And then going forward then, from position X to the back of photography, to the back of the table, which is also where photography target 1 is, was 297 centimeters. And then adjusting the laser pointer to the top of the tower was 171.9 centimeters from the ground. Furthermore, then the targets, photography target 1 was a picture. It's kind of hard to see there, but it is a picture of like an eye doctor test, how far can you read down. So this particular image, it was difficult for us to get the drone around to the very back to get that picture. And because of how shaky it was, the resolution wasn't phenomenal, but we could at least make out what it is. Then photography target 2 and 3 are very similar. In terms of in terms of like a desert type landscape, assuming from another planet, maybe Mars. And then photography target 4 on the tower was a blinking LED. We were able to capture several pictures of it, the LED both on and off as pictured there, kind of hard to see. And then finally, I forgot the last distance measurement from X to the solid collection tower. was 157 centimeters, and then a rough estimate of the height of the tower was going to be 14 centimeters. This is the offset, the height offset of where the servo motor is, as adjusting the angle only, even slightly made the laser dot go over the tower. So we're estimating that that is around 14 centimeters. Several, just running through maybe some potential issues with the data, is that for the distance, the distance data, using the triangulation data, I believe is accurate, just because you can have the height and then calculate the angle. But I will say the distance, let's say I want the distance from the very edge of the map of the unknown area to the table. That distance, I'm not sure, is extremely accurate, just because we can't get the drone to go out of the unknown area. So we're going to be a few, inches, maybe around 6 or 7 inches away from the edge of the unknown area. So there is some discrepancy in that data. Next, going on to the altimeter data, and kind of shown is why why the LiDAR unit exists and why we didn't trust the altimeter data, just because we obviously never flew the drone 890 feet. I mean, and talking to Dr. Lee and kind of consulting with some others, this, we are around, that, that height above sea level, but we are not flying the drone that high. Furthermore, yes, we could offset the height from sea level and then going forward, but just there is so much noise in the accuracy of the sensor that we do not really trust the data. So, but here it is anyway. We were unable to really get anything meaningful out of it, but yeah. And so next we'll go to the magnetometer data. Shown visually is the absolute value of the magnitude of X, Y, and Z, just because that's how the magnetometer collects the data, is where X, Y, and Z position is in relation to the sensor. The thing is that this range is very, very limited. So basically, it's not going to show anything meaningful on its own X, Y, and Z. So that's why, in terms of data interpretation, we chose to take the absolute value of the positions multiplied together to see where it is. And you could think, oh, a smaller value would mean that you're actually closer as opposed to a higher value. The only problem is it's extremely difficult for us to stably get the drone extremely close to each of the sensor units except the ones on the ground. And even then it will be a couple inches away, which is the maximum range. So the heights of the values, the higher values would indicate that we that we had found a magnetic field. And so near the end of the fly time is where we have the highest peaks, because disregarding the initial kind of setup at the beginning. So that we actually went to sensor position 2, which was on the table, the sensor target the slanted table. This was where we believe the magnetic field came from, just because that was the last target that we went to, because it was more difficult to get to than the other targets, which were flat on the floor. And finally, here's the temperature data from our sensor. This was a little bit of a disappointment, because we had tested gotten much better data previously. Unfortunately, this is a bit difficult to interpret. There was kind of a colder area around 8,000 mark or 80,000 mark for time, possibly because we went to sensor 1 first. This could possibly mean that sensor 1 was cold, or sensor target 1 was cold. Not entirely sure that just in terms of reality check, then this doesn't really make sense, but this is the data that we have. And finally, the sample collection. We were successful in collecting 1 cubic centimeter of solid and liquid samples. Our original sample collection did not necessarily work, so as you can see, we did resort to a tape method, and we did submerge a little bag attached to a attached to a rod in order to get the liquid. The picture of the liquid's kind of hard to see. There is a little yellow tint within it, within the vial. However, there is 1 cubic centimeter in both. Going quick now to the acknowledgements. First, the Minnesota Space Grant Consortium, of course, for funding our project. Next to James Flatten and Ben for being with us and guiding us through all the team meetings and check-ins. Next, Dr. Thelma Burklow, who is also there at the team meetings and has done a lot of the work at Concordia in terms of the drone club. And then obviously you guys, the Quadcopter Challenge judges, for taking your time to review all of our information and kind of grade us. So just a big thank you for your help and support throughout this project. And thank you very much.